Hello, my name is George, and my project for the Pro Summer of HPC was to parallelize the bond structure of a program called Solid 2000. Solid 2000 is a simulation program that treats systems that have symmetry in 3 dimensions, such as crystals. Electrons cannot move freely inside the crystal, so there are specific states that they can exist and therefore specific energies. A bond structure of a crystal is the energy that the electrons have inside that crystal, or rather, the energies that they are allowed to take. Those energies are also depend on where we are inside the crystal, and this is exactly what a bond structure tells us.
This is an example of a bond structure, generated by Solid 2000, and it shows how the energy changes along a certain path. The code also simplifies the calculations by utilizing the helical symmetry.
The helical symmetry can be explained like this.
If we take a small part of the nanotube and duplicate it like a helical spiral shape, we will end up with a whole nanotube. So for example, if we have a carbon nanotube, instead of 24 atoms unit cell, we end up with 2 atoms unit cell. This is the code that I built during the project. The process starts when the master sends a message to the slaves to signal the start of the bond structure calculation and the call of the corresponding subroutine. The master broadcasts the necessary data to the slaves before they start the main work along with the master. Here, both left and right, we have the same code when the bond structure is calculated. Do it is a boolean that is evaluated on every loop, and it tells the procedure to do the work or leave it to another procedure in order to create an equally distributed workload. If do it is true, it tells the procedure to do the current work, or else it sends the procedure to the end of the loop. If the procedure is the master and do it is equal to false, it calls MPI receive in order to receive the data from the work that a slave has done. Because we don't know which slave has the correct data, we have to use MPI any source. In order to determine from which slave to receive, we make use of the tag. In this case, tag is equal to K2, and K2 is the x-axis of the bond structure plot we saw earlier. This is a nanotube that consists of magnesium and boron that we use to make the benchmark. And this is the plot of the benchmark up to 1024 cores, where the red line is the perfect speedup. So with the current version of the code, we can calculate the bond structure in parallel. And the bigger the system is, the better speedup the code will have.